or draw wedge, sorry, then I don't see anything. The wedge is really the outline. There are other possibilities, draw lines. That's difficult to see, actually. If I draw the edges and disable the wedge, then you can see that this is just the limitations. Here I can also see the lines perhaps a little bit clearer, but I don't think that's so nice to see. If I look at the echoes, though, then if you're really fast, you can see the progress of a scan in the water column. I don't know how nice that is to see. The scans are the white dots at the bottom here. So the way I prefer to see it is really the wedge and the scans at the bottom. That's what I will do. A little bit further up, we have a possibility here on the online DTM, only if logging. That should be true. So we're only adding to the terrain model when we are logging data. Let's try to create a terrain model, at least prepare for the creation of a terrain model. You do that by right-clicking on the Artosonic here, and then you choose Build Online DTM. And now we get this dialog here. I can give it a name. I can call it Online DTM like this. The folder, the project folder, makes good sense. We'll just leave it as it is, and then a cell size of 25 centimeters is also fine. Something like this. And even default options. We can like to talk about these options, but I think this is something that I'll wait with until we come to NaviModel, because it's exactly the same thing and it's exactly the same dialog. So we'll do it there. So I'll say okay to it now. And then we're ready to start logging data. We do that in the same way we did it yesterday. I'll browse and select a run line for the vessel object, press select button. It's not already selected, it isn't. Select, and then I'll take the Aarhus Transit. Okay to that. But I can also have one related to the RV Kalman. This is the 21 meter plus 21 meter line. So now I have my left-right indicators active. And basically everything, all my data views to the right here are also active. I'll take the vessel object and select that and press the start line icon just above it to start logging. Now I am logging. The green background that says surveying on the label. At the top left here, I have this logging status tick mark with a green background. I think you can even see that I'm starting to generate an online terrain model down here because I'm logging data. If I go and have a look at the NaviPack logging, you see I'm logging here. And then in Naviscan Online, you can also see that in the caption up here, I'm logging data. My DTM window, if I zoom in by rotating the wheel of the mouse, it also works beautifully. Even the point cloud is being shown. And once again, if you don't see it, then the view options would be MBE average, and it'll be there. But logging can be seen in the caption up here, this SPD file. And here I have my terrain model. So if you select the terrain model, just click on it and press space on the keyboard, then the display will match the depths of the terrain with the current palette. This is the default palette. That's the rainbow palette that we're getting if we haven't chosen anything else. And that's basically how it should look. I hope you guys have also managed to get this to work. This is actually the last thing that we'll do on the online training. So if you have any questions, then ask them now. You can also ask questions later on, of course, but be a little bit more logical to do it now. While you guys are waiting to define a question, I can actually show you something that is useful when you want to do QC on your data here, on your navigation, NaviPack versus Naviscan, because you can make a range and bearing view here, view, new range and bearing view, from to. This could be then from the RV Kalman object to now the CRP. The CRP is the position coming from Naviscan. That's the only position we have in coming from Naviscan. So like this, Kalman versus CRP, they should be identical. There's some delay, of course, because it takes time to go via Naviscan and back again. But in theory, they should be the same. So here I have it. RV Kalman to CRP. And as you can see, they are not 100% identical. There's something with the height, apparently, that is a little bit strange, I think. Always an explanation to these things. It could be that I have entered the wrong. No, I don't think I have. Should be the same, of course. Hmm. Yeah, that's it's a little bit less now. So I think this is just some delay that we have on the movement. We have of course, the Betty is moving a little bit up and down. So I think this is just the delay that's causing this difference. It's also getting closer now. Yeah, even. But range bearing view is, of course, very useful. But here it's just you can say a QC tool. You can notice that if I look at my transponders from the beginning, no, it's a good question, Kim. I think I did mention it in briefly. It doesn't make any difference. It's just we are just instructing NaviPack and Naviscan to start logging, and they will log everything that's available. So there's no practical difference, as you say, between starting the survey from one or the other. There is one thing, though, that will differ, and that is if you have made a custom logging format where you're using KPs, distance along line, distance offline, then it really makes a difference, because if you start from Kalman, then it's the Kalman distance offline. If you start from the vessel, then it's the vessel distance offline, distance along line, etc. But apart from that, everything, you can say all the important things are really insignificant in terms of the difference between the two. In the old NaviPack, we had to define a priority. Here, you don't have to do that. And that is the old Hillsman's display, I mean. Yeah, so guys, this was online. I will stop my logging. And it does. I can even stop from RV Kalman. Stop logging. Now this one here. That's a bug. See, I was stopping from RV Kalman. It still says surveying. It's actually still logging. Huh. Never thought about that before. This is certainly. I have to stop from RV Kalman, or from the same that I started, but I can stop from the other one. Whoa. Hmm. But anyway, what you can see is that once I stop and I'm successful in stopping, then the terrain model is not being or having any beams added to it or scans. And also in Naviscan Online, it stops, and Point Cloud and the GTM are not being updated anymore. Right. We'll move on to NaviEdit. And we're using here the so-called NaviEdit Job Planner. When you open the NaviEdit Job Planner, it must look something like this. Might not be 100% identical, I will, by the way, stop my NaviPack here. And also now, of course, Naviscan becomes very unhappy because it doesn't receive anything anymore. So I will close here and also close Naviscan online and close NaviPack. It's not, of course, a must to do it, but it is really a good idea to not to confuse matters too much. I have my job planner, as it's called. I want to issue a warning now because the first day here is going to go a little bit fast. I don't have time to explain a lot. I'll do that tomorrow. The thing is that it's a little bit difficult to find the time to do all these different exercises in the right sequence. Today we're going to do cleaning on the data, but in order to be able to do cleaning, there's a lot of other things that we need to do first. And I promise you that I will explain all the things that you may have questions for. I'll explain that tomorrow. Of course, I'll do my very best to make it logical and to explain what is necessary for you to know. But there will be things that might confuse you. But don't despair, it will all be fixed tomorrow. I promise. But anyway, the Navigated database is based on a Microsoft SQL Server that we have installed. We have a free license, or that is actually without a license, so it's a free server that Microsoft is making available to us that allows us to create a database with a maximum size of 10 gigabytes. If you need more than that, then you need to have a license. But 10 gigabytes is actually quite a lot. And of course, you can have several databases. You cannot toggle between the databases if this is a problem. There are a lot of companies, even larger companies, that are actually not having a license. They're using the free SQL Server, as we are here. But what we will start with is to say file, database, and then I could create a new database, but I really want to show you here this dialog that pops up when I choose manage the local databases. Because I have all these functionalities to the right here. One of them is to create a new database. That's what I'll do. Press the new button, new, and then I will create a database, give it a name. On, off, for, like this. Maybe I should be consistent and then call it on, off 2023 underscore 4. You can see that there's already one there. That's called 2023 underscore 3. I call this one 4. The default location is also the location I want to maintain. I could place it anywhere in principle. Of course, it should be a location that's always available. It could be an external hard drive, but I will just place it in my local default location here. Something like this. When I enable user's default, it simply means that it will open, create the database and then open it automatically. So that's what I'll do. Okay to that. There you go. Here is the database. So I can close this dialog. I have an empty folder here. Got a new folder. You probably remember from the initial introduction that the flow in NaviModel is import, edit, export. We're going to import now. But before we do that, let me just show you the data that we're going to import. From the C drive, we have our project structure, but this time we'll focus on the data folder here. Data, and then it is NaviModel data. And at the top here, we have something called Nyborg data. Nyborg is Danish for Newcastle. Well, but it is Nyborg in Denmark, not Newcastle in the UK. Nyborg data is a folder called raw data. And here we have a tremendous amount of SPD files, as you can see. And those are the files we want to load. There's also here under Nyborg SVP, we have some velocity casts, 6 in total. We're going to use all 6. And there's even some more data, patch test, for instance, here. Data that was used for patch test calibration, as a matter of fact. And there's even a patch test report here. You might remember from the e-learning patch test module that you could create a report, and basically these are the results. There's a few other things that are of interest here. An overview in a PDF format. This shows, if I can find it. Oh, yeah, no, it's no. Don't know why I can't move this window. I simply can't move the window. Because every time I try to move it, oh, here it is, it will redraw the PDF file. But this is, wow. This is the data or the area. And actually, this part of the data I have removed. We're only going to work in this data here. This is a navigation channel or an approach to this jetty here, where there used to be ferries approaching. Nowadays, that's not the case anymore. But this is our data. So what we want to start with is to import Naviscan files. Look at the different importer types that we have here. There are a lot of, I was talking about third-party, for instance, Kongsberg EM files. These are data collected using the Kongsberg seabed information system. We also sometimes call these the .all files because the extension is ALL, and we can read the raw data in and interpret it directly into NaviModel. But there's a lot of others here. XTF is an exchange format. GSF also, generic sensor format. The FAO is also an exchange format. We have Ration 7K raw data files, the capability of loading those and editing them. So it's not just data that has been collected using the IVA software, also other, as we call it, third-party acquisition. software packages. Further down, we have NaviPack files. These are the so-called survey files, the NPD survey files or NaviEdit files that we saw. And then further down, ASCII files, which is using ASCII files quite a lot here, as a matter of fact. We'll be using ASCII files so much that you guys will be fed up with it. I promise you. But let's start with the Naviscan files. The SPD files also. It has the Naviscan interpreter as an importer wizard, a 5-step wizard. And you can actually skip some of those steps. If you do, then it'll use the settings from the last time around. But this is training, so of course we'll use all or show all 5 pages. And then there's something here, use time from raw position string. This is an item that has been enabled because we learned that people forgot to define use time in Telegram. Let me show you what I'm referring to. I'll just open Naviscan config. Our 5 here, or use time in packet. If this has not been enabled, the possibility is still there because the time is, of course, part of the package that's being received. But if people forgot to enable this, then we can overrule it by enabling use time from raw position string here. And we'll actually do that. So both these are enabled. I'll add or press the add button and then try to locate my data here. In the data folder, NaviEdit data, Nyborg data, raw data. And then I'll simply take all these SPD files, select the first one, go to the bottom, press the shift button in, and click on the last one, the one that's called 113. And open. This is the first step. Select the files to import. The next step, it gives us the possibility to filter data. I can tell you already by now that I'm not much in favor of filtering during import. We can always change these settings in the header editor. The header editor that allows us to change general settings on the different blocks in the NaviEdit database. In this case, we're loading SPD files. They become SPD blocks once they are in the NaviEdit database. We can change all of these settings when we are there. So I'm not going to talk much about it at this stage here. I can tell you one thing though, and that is the first 2 items here, manufacturer installation parameters. This is something that is relevant if you are using or if you are distinguishing between transmit multibeam array and the receive multibeam array. In principle, a multibeam have a transmit array and a receive array, and we can take advantage of our knowledge of how these are separated relative to each other, position-wise and offset-wise. If we have set it up, it's not set up in our data here, but if it's set up, then you can define the offsets in Naviscan for the TX, that is the transmit array, and the RX, the receive array. But NaviEdit can overrule those settings because NaviEdit will just look at the driver that you're using And then it has a lookup table that says, okay, with this kind of an instrument, the offsets are this and that, at least by default. But they could be different, of course, physically on your configuration. But if you're not too sure about what the online guys have done, then you could, or if you think it's wrong, then you could enable this one here and thereby overrule the offsets that were used online. But we don't have any reason to think that this is not correct. Online, you can filter data. We didn't talk about that in Naviscan, but it is possible to apply some sort of filtering. This could be, for instance, maximum depth or distance from the transducer and stuff like that. And of course, it is important always to emphasize that those filter settings doesn't have any impact on what you are logging in Naviscan. You're always logging everything. You can say, okay, I don't want to see data from 25 meters and down. But the data from 25 meters and down will be logged nonetheless, but they will not be shown online. That is an important difference to take into account. You can filter online, but Naviscan will log everything. Of course, if you are filtering in the multibeam firmware, then Naviscan can only log what it receives. And if you're filtering already in the firmware, then of course it will not receive data that's being filtered away. And that will not be logged then. But the thing is that for an SPD file, there is only one filter settings possible. That is the last setting. So if you have changed those settings on the fly during those 20 minutes of acquiring data, that information is lost. Naviscan will only remember the last or log the last setting that you were using. And this is also one of the reasons why I would never dream of using this setting here. Yeah, filter, command to all. We can have a set window and X window. This is a cross track. Set window, of course, is in the Z-axis direction. But by default, we have 20 kilometers in each direction, which of course is the whole world. Yeah, we also have something that we call beam quality threshold. We are working with a quality distribution in the IVA software that is both in NaviEdit and Naviscan between 0 and 15 when we talk about multibeam data, 15 being the highest quality. This is something that we inherited from Rayson. I was telling you that we were creating NaviBet, and these are the Rayson quality distribution numbers. If we are acquiring data from other manufacturers, then we will remodel their approach to match our approach. So a 15 quality is always the same in NaviEdit. We can filter, but at this stage, we don't know anything about the distribution, so we're not going to filter anything. Yeah, these items down here, this is what I will skip because this is certainly something that we can do later on. This is also related to filtering. The next step, I'll apply meridian convergence. That basically just means that we're expecting to have logged true north related gyro readings. And then on top of that, we will apply the meridian convergence so that we can calculate in a gridded environment that NaviEdit is working in. NaviEdit is always working basically in flat Earth coordinate, that is gridded, map projected coordinates. Therefore, this is default, and this is also what we will use in 99.9% of the cases. TX sound velocity, this is the online sound velocity that if you have a multibeam echo sounder, or the modern multibeam echo sounders, flat array multibeam echo sounders require an online sound velocity reading that is observed next to the sonar head. The multimeter sound is using that for the beam forming, which is basically calculating the returning angle of each individual beam coming from the seabed. It needs a very accurate and constant sound velocity readings. These readings are logged in the SPD file, and we could, in principle, use them. You have done NaviModel, you know that if we don't have anything else, we will, in NaviModel, use the TX sound velocity by default. But here we are saying, I want to use the TX sound velocity in a certain range between perhaps -1, that's 1 meter above the sonar head, and down to 10 meters. And then for the remaining, we will use whatever else we have specified. That could be a sound velocity profile. I don't think I would ever do this, because I would be more concerned about what happens in the overlap between those two, or when we jump from TX sound velocity to the TX sound velocity profile. Could there be some mismatch there? And then I think that would actually reduce the quality of what we are doing. So I will use a sound velocity profile rather than something like this. We can reduce data, but I want to import everything. I want to use all my data. I don't want to reduce anything. Next step would then be, yes, I want to use the SPD geodesy. You saw how we set that up, and that has been also set up correctly here. If you don't want to use the SPD geodesy, it is possible to define an alternative geodesy during import. That's not necessary here. So I'll go to the next step. Here we can apply or add notes to it. It's also possible to show the report. This is metadata on whatever we are receiving. And I can also edit the bathyocean setting. This is recalculating pressure to depth. But the data we have here, I don't think I have mentioned it, but the data we have here is surface-based, so this is certainly not relevant. So I'll say finish now. And in this folder here, just a gentle click, then I can change the name to hydrographic, because this is hydrographic data. Then I highlight it and create a folder. This will then be a subfolder. And I will call this folder here, Naviscan, to indicate that the data here is Naviscan data. Select it and say OK to that. Now, Naviscan is showing me the first report, the first metadata. It makes good sense just to go through it. You can see the data was collected on 19th of August 2011, 11 and a half years ago, something like that, a little bit more. 4 minutes and 22 seconds of data. Time zone, UTC +2, so that's basically, of course, somewhere in Denmark here. We are 1 hour ahead of UTC, and then we had 1 hour daylight saving on top of that at this particular time. Mount offsets here, and also mount angles. Here is the mount angles of the multibeam echo sounder. Here are the offsets of the motion sensor. There are no mount angles or C-O values for gyro motion. It's probably been defined in the instrument itself. Further down, number of records, navigation record 263, 4 minutes and 22. This is 262 seconds. So basically, one extra here at the end. What we can say is the navigation comes from NaviPack. This is most likely a position expanded to Naviscan that we are seeing here. We also have GPS height. This is an RTK height that also comes from NaviPack. Gyro records, 6,500. That is approximately something like 25 hertz update rate for the gyro, and same for the motion. The Bethy here is actually the same as the GPS height. So this is the RTK Bethy that is coming from NaviPack. Motion, same as gyro. Echo sounder, something like 12 scans per second, approximately. And further down here, you can see that we have 256 beams per scan, and that multiplied by 3,724 gives us a total of 953,000 depths. The quality distribution here, look at that. Quality 13 and 14, those are reasonably high qualities, and we'll simply make a note of that, quality 13. This would then be the filter setting that we apply just to get rid of these 150 that has quality 0. No critical latencies observed. That's good. We have some geodesy information here. Down here, a time difference, maximum of 5 milliseconds between the absolute and the relative timestamp. That is very good, as a matter of fact. And this is shown because we chose to use time in Telegram initially when we imported it. So the maximum discrepancy between what we would have used if we hadn't enabled that and what we are now using is 5 milliseconds, which is actually nothing. I'll disable show report, and then I will say OK to the data, and now Navi Edit will just continue loading the data. Now, let me go back to the patch test calibration while it's loading. And then look at the results. Still running. Here are the results. I'll just make a screenshot of this one here. This is actually a report that I have made because at the time when this data was collected, we had a different tool in the IVA software for the patch test calibration. And I simply took the opportunity when I was doing a training course to recalculate. We can have a look at it because these are, we can take, it was a lot more complicated. This is the pitch calibration report. See how that looked? It was subdivided into the different components here. Pitch 2.040. Here, it was 1.87. So there's quite a significant difference, as you can see. 1.87. I can close the report and then look at roll because the roll will be very similar. Roll is always the easiest. It's also the most important one to define. See the roll 0.424. Same as the new result. Let's have a look at the heading. Up here. Very close to 0, as you can see, 0.008 or minus 0.01, because we only use two decimals here, and the new and more correct one is minus 0.27. So we will bear this in mind. My blocks are actually all loaded, as you can see here. It's very likely that you have not completed yet. I have a brand new computer, as a matter of fact. It's only a month old, something like that, 1.5 months. And the reason why I got it was that my previous computer was getting too slow. I couldn't keep up with the people that I was training, but now I can. There are a few things that we need to do here. As a matter of fact, I am not going to do everything now, because the only thing we need to do now is to load the data into NaviModel and clean it. Let me just show you briefly the flow that you might remember here. From the first day, this is the data flow. So basically, we have imported data into NaviEdit, and we will now load the data into NaviModel and perform the cleaning. Once we've done that, we will write the cleaning status back to the SQL database so that we are ready to continue tomorrow. The thing is that the cleaning takes a lot of time, and I don't want to use important training time for that. We will use exercise time for this cleaning. So that is basically the key. But in order to optimize the cleaning, I want to apply the mount angles onto the data, because otherwise we'll have some overlap issues on the data, and that will deteriorate the cleaning status for us. So I will take from here the Naviscan folder, right-click on it, and activate the header editor. When I do that from a folder, it will simply load all the blocks that are in that particular folder into the header editor simultaneously. And that's what I want to do. Header editor. This takes a little while. So let me just hear if you guys are where I am right now, or if you are still a little bit behind. Just give me that information on the chat. Long has loaded, that's good. Kim is also up to speed. You guys have good computers, apparently. Illy loaded too, yeah. So how about Raymond and Samuel? Are you also where you should be? I'm a little bit reluctant to continue until we're all here. Well, I don't know what to say, but I take this as a yes since I'm not getting any response for you. Samuel is loaded. That's good. So then we need Raymond. But he's also coming now. Raymond is typing, I can see on my chat window. Must be a long story. Okay, so you are confident. That's good. So you had a problem with your internet. Yeah. Right. What I have done now is I have loaded all these blocks into the head editor. And now the first tab here is the instruments tab. And I want to change these mount angles, the result of the patch test calibration. I do that here from the multibeam, double click on Ultrasonic 2000 series, and then the mount angles here. I must specify those, and they are certainly not identical to what we have. They're probably not even identical to the data or the previous patch test calibration. Sorry, I know that they are not. I need to be able to. So there's something with the sequence here you have to be careful with. 0.42. Like this. So this is basically how it should be. And remember, this must be in the mount angle tab, not the offsets, but the mount angle tab. I'll send it to you on the chat. And now I'll say OK to this. And also OK down here. And what is important is to acknowledge this. This is information. Do you want to apply changes made to these pages? Yes. This is important because if you don't, then you just have the head editor open and it hasn't written the new settings back to the database. So in my dialog here, I can right click and choose refresh. I can also just press F5. And then the header says OK plus. That means that I have inspected the header information and I have applied changes to it. Right, let's now, yeah, this is a reminder from this morning. I will open now NaviModel. And I will start by creating a new project. This is like what we saw in the HealthNet display, new project. And here again, I need to define the project name. I'll call it cleaning because I'm only using this project for the cleaning. I need to choose a location. I will browse and then find our project folder, NaviModel. This is the folder. It looks like this. And then I will create the project. Now, this is a little bit like what you saw in the health display. You probably used it like this. We have two different themes in the health display as well as in NaviModel. Those two themes are the light and the dark theme. I'm always using the light theme because it's a lot easier for you guys to see what's going on if I do that. So I can modify by choosing settings here, options, and then the theme, the light theme. In brackets, it says program restart required, and that is exactly what I'll do. I will say acknowledge, say okay. I will close NaviModel again, and then I will restart. And this time I'll use the project that I have here, cleaning. And now here is my NaviModel. It looks very similar to what you saw in the health display. There's one important difference though, and that is what you see here. I have a connection to my NaviModel database. I have this connection because my NaviModel database is in compliance with this NaviModel version. Otherwise, I wouldn't see the database. Now, here under hydrographic, see the same structure as you saw in NaviModel, the job planner. Here in Naviscan, I can right-click and choose import MPE points to DTM. It's a little bit similar to what we saw in the health display when we said create DTM based on the multi-beam data. So import MPE points to DTM. And of course, I'm going to use all these blocks. Say okay to that. What are you going to do? I'm going to create a single model. Otherwise, I'd have 113 different models. I don't want that. So just one model. And I could then call this, I'll just call this one cleaning. The cell size doesn't matter so much, but I will use a cell size of 20 centimeters. Because the reason why it doesn't matter is because cleaning is not depending on the cell size at all. We still use default options, and I will show you how we can change that tomorrow. Default option, and then okay to that. And now NaviModel is starting to load the data. You can see that in the lower right corner here, there's a queue of 120. But I can also open a views here that I call the job list, like this. Job list will show the current jobs, those that are activated and those that are in the queue. You can see that I have a tremendous amount of cores. I can't remember how many, but more than I used to. And NaviModel is able to use all these cores for the majority of the functionalities. Import from the NaviModel database is one of those functionalities that are using all the cores that are available. The last block here, the 1 to 6, that is a huge one. I can't remember how big it is. Here it is, 14 minutes and 27 seconds. That's a little bit bigger than the others. Now it's importing the so-called blocks, and it is now creating the terrain model. It's called calculating the surfaces. We also call that indexing the terrain model. I'll give you more details on how NaviModel is handling these terrain models tomorrow. I seem to remember that there's around 130 million points, so this is bound to take time. 130 million points on this single model, but I think mine is reasonably fast, nonetheless. Yeah, but I can't help you there, Don. Sorry about that. But Duan, you are using your own computer, am I right? I think everybody was using their own computer. I'm a little bit in doubt about Kim because there was some discussion about whether you wanted to use one of our remotes. But I don't know what the conclusion was. You're still using your own. That's good. So Ili is using the virtual. Okay. So are you finished now, Ili? Or are you still? Yeah, well, 2017, that's Ili 77%. So I'm faster than you. That's great. Duan? Samuel 60. But as your computers are not that slow, I would say. 2017, yeah. I think the main limitation is really the graphics card. That's normally what is causing problems. See, here is the terrain model. And mine is also a Dell, but this is 2023. The old one was 2018, and that was slow. And yours is 2017. I could still keep up, but not as good as I would like it to be. We're going to do cleaning now, and I'll explain to you, try to give you as many hints as I can. In order to do cleaning, we need to open the point cleaning toolbox here, found under views, the point cleaning toolbox. Now, the point cleaning toolbox here contains all the tools that we have for cleaning. The top ones here, EC3D and SCAN, they are the automatic cleaning tools. Further down, we have what we call the semi-automatic cleaning tools and then manual cleaning tools. Manual cleaning tools also include reject. You can reject an area. That means clean everything in the area or remove everything in the area or accept everything in the area. And of course, one thing that's important to emphasize is that you're not removing data. You are changing the cleaning status. And that means if I reject something, I can always bring it back in again. Or if I clean something, I can always bring it back in again. Now, if I can zoom in, of course, here in this area, I can open the DTM toolbar like this. view toolbar, DTM toolbar, and you recognize a lot of this from there's a display DTM toolbar like this. This is the DTM toolbar. One of the tools is this one here, show points. I'm now looking at points. This is not the terrain model. These are the points that have been used to create this particular region. But of course, these points are all over the place. But this just tells us that we have, well, quite a lot of density on these points here. This rectangle is 10 by 10 meters by default. If you go to the map view properties here, views, map view, then the box size down here in the properties can be changed to maybe 100. So this means that it's 100 by 100 meters. And now you're starting to see something here. You can see that if we go zoom out, you can see that there's a lot of noise down here that we need to get rid of. I could have removed this in NaviModel by making a vertical limit, but I chose not to do that because it's easy enough to clean. But what I want to show you is this aspect here, because this is a little bit tricky. We have a key side here, as you can see. And the automatic cleaning tools are not very efficient in an area where you have a vertical structure. And NaviModel is not, the NaviModel terrain model is not very efficient when you have a vertical structure. We say that NaviModel is not really a true 3D tool in terms of DTMs. We call it a 2.5D because the cells have a horizontal distribution. And that means that a location here, if we have a cell here, then we can only have one depth, even though the vertical structure has a lot of different depths. That means if I disable the view here, then you can see the terrain model looks strange. But that's reflected on the automatic cleaning tools, as a matter of fact. But let me just start by showing you how these cleaning tools work. But before I do that, I want to change. First of all, we have up here, we have the cleaning. Under surveys, this is the terrain model. You can see down further down here on the properties that I have 138 million points. You can also see further down that the surface type is average. This is fine, but the color mode is depth. I want to temporarily change that to something else. I want to change it to cleaned regions. Now, it's all gray. That tells me that I haven't performed any cleaning yet. But I want to do some cleaning. I want to start by showing you the SCAN score. The SCAN score cleaning tool here, this is an automatic cleaning tool. It's by far the easiest of the automatic cleaning tools to use. I will start by just creating a small region down here. If I click on it, then I get a selection tool, as you can see here. Polygon is the default, so I'm creating a polygon that contains some of my data, and by double-clicking. So click, 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 double-click. SCAN will now perform the first step, of the cleaning, in which it is defining, you can say, the threshold values or the quality values. This is always the first step. I can go directly to the second step by choosing Clean Now here. But I can also just close, and then I can show you how you can access those under the cleaning tool here. See, regions, scan, this is the one that I just performed. The scan score, this is the first step. So I can right click on it and choose here to clean entire area. I can also clean a part of it, but I will clean the entire area like this. And now you can see the point here. I'm trying to find some values. Basically, even though I'm only looking at 100 by 100 meters here, my selection here has an impact on everything that I'm doing. All this area, the entire area. But look at what happens when I change the threshold value. More and more points are becoming green. Green means that they will not be cleaned. And red, of course, means that these are marked for deletion or cleaning. Yeah, be careful and not use a value that is too small. But it's a good idea to pan around and see the consequence of the settings that you have applied. You see there's a little bit here. This is actually an overlap. But I guarantee you that if we hadn't applied the mount angles, the correct mount angles, then these overlaps would have been huge. I can move around and check and see that this looks okay. Maybe I can have a look at the outer skirts here and see what happens. Also underneath. And notice that it's displaying only these points in the camera position. So if I move outside, then I don't see any points. So I need to move, pan inside, and then here it is. Now I'll say okay to this. I'm happy enough with this value. And now it is, we call it's re-indexing the terrain model. That means it's taking the depths into account and updating the terrain model. And it certainly, I'm sure you'll agree with me that it looks better now. I can have a look at raw data. Now you see a similar pattern to what we saw before. All these points down here have been deleted or marked for deletion because they're still there, and I can bring them in again if I want to, just by here, right click on score and choose remove. This will undo the cleaning. And of course, I don't want to do that. It actually looks nice. In a normal scenario, I would probably do the cleaning on everything in one go. The only exception is the area around the key sites here, because SCAN cannot handle that. Simply cannot handle it. So let me show you how you can fix it. First of all, if you go into 2D, then you don't run a risk of removing something that you don't want to remove. Because the same as in the health display, if you are in 3D, it's a little bit difficult to see where you are. And all our selections here are really 2D selections. So I'll go into 2D selections here, and then I will take reject, and then I will simply remove, go close to the key side without getting too close, like this here, and by double clicking. So now I'm removing everything that is outside the key side area. Now they're gone, and I can do the same down here, even though that's not so much down here. All right. Maybe I could go a little bit closer to the data here, but I can also take that as part of a manual cleaning session. The manual cleaning tool is the point editor that you see here. Point editor, and again, I have a selection like this. For the point editor, you need to be careful because if you load too much data, then the point editor cannot handle it. It can handle, I think, about 500,000 points at a time. So I end by double clicking. And now, as you can see, I have my data in here. If you go to the top left here, you can see that there is actually some outliers at 96 meters, something like that. I can, of course, pan by rotating the wheel. I can rotate, I can zoom in and out. But I can also, I have two tools. One is the eraser tool. That is by far the most efficient one. I'll take that. This is the eraser tool. I can change the size of the data I'm erasing by rotating the wheel of the mouse. And then I could even go close to data like this. Then I can press this one here, fit palette. See, I still have 96 meters somewhere. Let me zoom out. I think it could be one down here. Press the space bar, and then it toggles to the next tool. Fit the palette. Now it's gone. As you can see, my maximum depth is 13 meters. So let me have a look at this from the top. And here's space again. And now I have the cleaning tool. And of course, I can also just do like this. I don't expect you guys to clean this 100%. That's not the purpose here. What I really want you to do is to try the different tools that are available. That's the main thing. That's the main purpose of this exercise here. I don't know why there's also something up here that I need to get rid of. Fit the palette. Now this is actually color by block. Can't get much out of that, but like this. Now it looks actually quite nice. Notice that I have approximately 300,000 points in here. 4.2% of those have been deleted. You can undo by pressing Control Z, by the way, that's also worth knowing. So don't save or anything like that. Just close the window. And then you can choose to save the changes. Yes. Now, look at this. You can see down here, I've done cleaning. Up here, I have also done cleaning. I can see that on the colors, which of course is very nice to be able to do that. Let me just take another one. Space. Now, fit the palette. 18 meters. That seems like If you find that it's a little bit difficult to get close enough to the data, you might want to do a vertical exaggeration. If you press the shift button down and rotate the wheel of the mouse, then you get this vertical exaggeration. I think makes you look space again. Now I can rotate and have a look at the data from the top here. Don't be too shaky on your hands, because then, like this. I think this is fine. Fit the palette. Yeah. Close and save changes. So this is the second tool. This is the automatic tool, and you need to do this for all the area around here, where you can see that there is a key side. You can still do the automatic cleaning tool close to this one here, but let's have a look at the alternative, the so-called histogram plane cleaning. This is a semi-automatic tool. We need to define a plane. So this tool is good in a reasonably flat area. I'll just do it in this area here. And by double clicking, and here is my histogram. If I zoom in, then you can start to see the data. The thing is that I also need to zoom in here. I need to go into 3D, otherwise I can't see it underneath. Look at that. There's so much noise underneath. The guys that were collecting this data had simply too much power on their multibeam. That's why they have all this noise. But look at what happens if you move these sliders. You can say that the default values are actually quite good. This is above. And this is then below, as you can see. So I don't know how efficient it is. There's a tremendous amount of data actually here, even though it doesn't look like a hell of a lot. But the thing is that we have a logarithmic scale on the y-axis. The y-axis shows the number of points. And that is, of course, in order to be able to make a better selection. You can change this by saying this is linear, and now you can really see that there is practically nothing on those two sides here. Still working the same way, of course, but it makes you a lot more confident if you're really using the logarithmic scale, something like that. So I can say apply now, and then you can see that it already looks a lot nicer. There is another automatic tool that's called histogram spike shooting here. Same as the one we just saw, but it's called spike shooting basically because we are just using a circle. not a plane. I can change the size of the circle by pressing the Shift button down and rotating the wheel of the mouse. And then I select, and as you can see here, I get a similar selection tool as the one we just saw. This is still a histogram. It is actually so that the default settings, the settings that are suggested by the tool, are actually quite good. I need to go. I'm a little bit reluctant to go closer than this, so I'll say apply to this. And now I also have that. So one thing I need to show you or tell you is that you can do cleaning on top of cleaning. I can do scan score, for instance, here. I can, let me do it like this. This is I'm selecting this area. I'm trying to go as close to the data as possible. This is not a key site, so here I will do like this. It's not a problem to, as I said, to clean on top of cleanings that I have already performed. So I can basically just double click here, and now scan will clean, or at least do the first step of the cleaning on the entire area. And of course, in these areas, it only get the information from the data that we have not removed during the initial cleaning, the histogram cleaning tools. And this takes a while. The whole idea with this is that the computer is working for you. You can just lean back, grab a cup of coffee, and then when you come back, it has done the cleaning, or at least the first phase, the first step. And then you've had your coffee, you can let it do the second step, and perhaps you'll go and have another coffee, even though the second step doesn't take that long. There is in the point cleaning toolbox at the bottom, there's a function here called Save to External. With this, you can write the cleaning status and only the cleaning status back to the NaviModel database. And you guys might be concerned about what happens if you have forgotten to do that. That's not a problem, because one of the things that is typical for NaviModel and the handling of terrain models is that it is really the terrain model is living on the hard drive. Whatever I have done so far is on the hard drive. I can show that because I can right-click on the cleaning project here and say, open the topics folder. Remember, this was also the folder we had in the health display. Open topics folder. Here is my terrain model, which is being updated constantly. This is the score patch that I created, the first one, and there will be a new one shortly coming up, written here. But the cleaning DB is always updated. So you don't run a risk of it. Even if your computer crashes or whatever happens, you still have your DB file. And with my many years with so far I've never experienced a DB file that was crashing. So that is, I hope, reassuring for you guys. Still working. And of course, that is taking time. In the meantime, I can show you my exercise notes. By the way, I owe you an apology from yesterday, because when we were going through the exercise, I was talking about a port number 5030, but in the exercise notes, I was asking for 6234. That's just because I had two versions of this, and that's apologize for that. I shouldn't have done it. And there were even Ili did both outputs. I was very impressed with that. So let me have a look. This is day number 3 exercise. The cleaning is the subject. The exercise today is related to cleaning NaviModel. We have different cleaning types or methods: manual, semi-automatic, and automatic methods. As I have already told you, in the current context, we will be focusing on all these cleaning tools, SCAN and or EC3D. We're not going to use EC3D here, as a matter of fact, because I don't find it to be very efficient when we talk about multi-beam data. We will use EC3D for point clouds later on. Semi-automatic, histogram, plane cleaning. Cursor on seabed. What do you mean, Duan? I simply don't understand your question. Yeah. Data is the hydrographic data. We have done all of that. Skip everything that's related to EC3D. Basically, yeah. Write the clean data back to Navi. What I want from you is actually, as documentation here, is just a few screenshots. I will detail on that when I send you the exercise notes. Okay, I see what you mean. I was actually explaining you this drawing. The point is that now I can't see anything either. See? I need to move my view to the area I want to look at, because this box will always be centered in the middle of the map view. I think that's what it is. So you just pan, and everything here, and that's also important to understand, everything here is actually, even though this is 3D, everything here is based on a 2D approach. So if I want to look at something there, then I need to double click on it, because then that particular point will move to the camera position or the center of the map view. As you can see here now, I don't see anything, but if I want to see something there, then I just double click on it, then it'll move there. And now I have it. I hope that's that answers your question, Duong. Yeah, there's some things you need to get used to. after a while, this becomes a logical thing for you. You don't even think about it anymore. But you're still beginners. I don't know. Has anyone tried NaviModel and NaviEdit before? Any of you? Please let me know if you have. That is, of course, interesting for me to know. So, Kim, you've done some. Have you tried the cleaning tools? Drawing is new on this, yeah. Yeah, first time for Raymond as well. You haven't tried the scan? No. Kim. Billy, have you tried the scan? I will actually send you a PowerPoint that I made a year ago or so about cleaning in NaviModel, but I'll go through it tomorrow, as a matter of fact. Right, guys, we've come to the end of the training today. I'll send you the exercise notes, same as usual. But please, the important thing is not that everything is 100% cleaned. The important thing is that you try all these different tools. If you accidentally delete something that you shouldn't have deleted, then you can actually press the accept here and then say, I want to accept a certain region. Then everything inside that region will be uncleaned, so to speak. But screenshots, typical screenshots of what you have done, and then just spend some time working with the different tools. That is my recommendation for you guys. Shouldn't be as time consuming as I have a feeling some of the first two training days have been, at least for some of you. Okay, guys. See you tomorrow. I will go into mute mode and then send you the exercise notes in 5 minutes time or so.
Hello, is it possible to get help for the issue I had?
Samuel, I simply cannot hear what you're saying.
I
Why
can
don't
hear
you
you. Mhm.
come again?
Is it possible to get help for the issue I had at the beginning?
Why don't you write it on the chat, because I cannot understand what you're saying. Sorry about that. Oh yeah, but yeah, I'll have a look at it, Samuel. I've seen your mail. Good, thanks for reminding me. I'll have a look at it, but I want to send these exercise notes first, and then I need to have something to eat my lunchtime, and then after that I will contact you and see if I can find something. What is wrong? Yeah, okay. I'll I'll have a look at it. Bye now.